Hello everyone. Welcome to What's New in NXCAM 1980. My name is John Vincent, and I'm based out of the Milwaukee, Wisconsin area. I've been an NX user for approximately 18 years, and I support both the CAD and CAM spectrums of this software. Through my time working in both the aerospace industry as well as consumer product manufacturing, I'll bring a lot of hands-on experience using NX as an end user to the table. So that'll bring us into what's new for manufacturing content in the latest series release of NX. We're going to discuss a few different topics today during this session. Some new operations that have been added to 3-axis contouring and 5-axis contouring operations. We'll be looking at the new MultiAxis Deburring operation, which has been a really nice enhancement. If you stay up to date on the latest series releases, you'll know that Siemens has added a new deburring operation as for planar milling operations, as well as the ability to program modeled chamfers on your geometry. And these are using your typical chamfer mills. Well, the multi-axis deburring operation is going to be a little bit different. This is going to be dedicated for using ball mills, tapered ball mills, or spherical cutters to go ahead and deburr your part geometry. So we'll talk a little bit more about that in depth here when we get hands-on. Rotary roughing will be the next operation type that's been added to the software. These are dedicated operations aimed at 4-axis machining or 4-axis toolpaths. Of course, these can be utilized on 5-axis machines as well. But really great functionality inside of these operations that we can utilize. Standard square corner end mills, bull mills, ball mills, as well as fully support IPW and other nice functionality like bottom-up cutting. Being able to utilize rest machining techniques and fully be able to limit various regions that you want to machine on your part geometry. Guiding curves is a relatively new operation. I believe it was added to the software around NX12 time frame. And this is going to be specifically looking at the variable axis guiding curve operation. So this operation has been enhanced over the past releases since its inception, and we have a few more enhancements to this operation that'll enable us to better control our tool axis. We'll be able to now apply wall geometry, assign wall geometry and wall stock, as well as utilize multiple depths of cut. So really some great enhancements here on the milling side of the operations. If we turn our attention to turning now, inside of NX 1980, we're able to fully support prime turning, Sandvik prime turning. We'll dive into what prime turning is in a little bit and go ahead and review those new operation types and the new tooling types that go hand in hand with the operations. We also have a few productivity enhancements embedded in the software now. The first one is going to be the ability to create tool holders from solid model geometry. So this will enable you to go ahead and download 3D models from any of your tooling vendors and generate the 3D model, the tool holder model, based on 3D geometry that could be imported as some other native data or parasolid, step files, anything like that that you can go ahead and import into NX. And of course, all this data can be reused for future tool assemblies by saving data off to your tool library. Going on from there, we have a new tolerance class that's going to be available in both of our reamer tools and boring bars. This will allow you to specify a tolerance class, like an H7 tolerance or an F7 tolerance. So you know not only the diameter of the tool, but also what class fit or size your feature will be based on a specific tool. And will enable you to more quickly search for your tools or embed this new tolerance class into your feature-based machining rules to better automate tool selection. And the last topic we'll talk about is going to be regarding NC simulation and an improved workflow for multi-setup IPW. So a typical scenario would be if you're running multiple operations on various sides of your tombstone on a horizontal machine or any type of fixturing, perhaps just two vices on a vertical machine, and we're doing op 1, op 2, flipping the part over. So a new workflow on how we can go ahead and transfer that IPW and all the data, reducing the number of user clicks and choices and geometry selections, as well as close some little gaps that existed in previous versions. All right, so we're going to go ahead and dive right into these initial milling topics. And we're going to look at this new multi-axis deburring operations to start off here today. So inside of the multi-axis deburring, we actually have 3 new operation types. And so we'll see those new operation types are going to go ahead and be located inside of your mill contour, mill rotary, and mill multi-axis operation types. And here we can see the various operations available in the Create Operation dialog. So at this point in time, you can see that we have some various 3-axis toolpaths, 4-axis rotary toolpaths, and full 5-axis simultaneous cutting available to us inside of these operation types. And all of this is done with automatic geometry selection and very few parameters that have to be specified to control our tool axis types. And so we'll see inside of each operation we have a different tool axis intent, whether it's 5-axis simultaneous, 4-axis rotary, or we're just rotating about a stationary axis. We can use a 4-axis +1 auto tilt. So this is a 4-axis strategy on a 5-axis machine where we can apply some tilt value to change our cutting location on our end mill. And under mill contour, we have our 3-axis intent, where we're going to have no rotary motions involved in our cutting, or we can go ahead and transition to 3+2. This will try to maintain its stationary axis when possible, but also enable the rotaries to get involved and reposition the machine or the tool axis to accommodate your part geometry. So here, as we look and see how you can transition to our 3+2 intent, we also have these different basic alignments. So when we're normal to contour, we're going to apply a max angle, and this is just simply stating, what angle can we allow our tool to tilt. In this case, we're up to 45 degrees. And NX will go through and generate the tool path, trying to maintain that 45-degree tilt throughout the tool path. And if we go ahead and change the basic alignment to fixed to main axis, we'll really get far less rotary motion inside of this this type of operation. However, it's definitely worth noting that we will still see rotary motions both while cutting and repositioning using 3+2 intent. So if you have a machine that maybe has a little bit lower dynamics, this can be a good option to try to maintain a fixed axis orientation until it's really required to go ahead and change to a multi-axis. We'll see you have nice smooth connections between all the regions here, and this is related to the new traverse type called blend spline. So we have this new ability. This is the default option. However, you can turn that option off and go to a more conventional type traversal motion if your machine doesn't handle linear interpolation in rapid modes. All our clearance options are going to look very similar to any NX operations that you're currently used to, so nothing out of the ordinary there. We have a few settings here for inner corners, how to handle this. We can see we have the relief option. This is just going to clean up any interior corners when you're doing the pencil line tracing type operation. We'll look at that more in depth a little bit later. We can also limit our geometry selections by a few different ways. Currently we're selecting all of our edges automatically, but now we want to specify a height region and select only the edges between two planes. So by picking a start point and an end point, as well as a reference axis, and then generating our toolpath, we'll limit our toolpaths to that particular region to limit what regions we're going to be machining on our part file. Of course, we could turn off our automatic edge selections and do any manual selections we wanted for specific edges, or go ahead and actually exclude edges that were selected automatically. Pretty flexible operation. So next we'll be looking at the new rotary roughing operation. So we've had a finish floors, finish rotary operation for a number of releases. And however, this operation will now close a gap that's been around for some time. There's a number of different ways that we could program similar toolpaths, but a little bit more cumbersome than maybe necessary. And this new roughing operation will be a great benefit for anybody that's using 4-axis machines and does a lot of cylindrical parts. So pretty interesting strategy that's used here. We have this automatic selection between follow part and helical cut patterns while we're generating this operation. So we'll be able to, the operation will go ahead and automatically specify and try to maintain a helical cut pattern or a spiral cut pattern throughout our part until we encounter some more detailed geometry, and then the toolpath will transition to more of a conventional follow part. So we actually have two modes with this operation. We have a cylindrical mode and a conical mode, and you're going to make the selection based upon your type of part geometry. And we don't have the limitations from rotary floor. Here we can use square end mills, bull mills, and ball mills. So looking at the cylindrical depth mode option, we're simply just going to go through, specify an axis of rotation for our particular part. And we'll see that our cut type is going to be this hybrid between follow part and helical. And if we play our toolpath and material removal here, we'll see we're going to be maintaining a helical toolpath until we encounter some different shoulder geometry, and then NX will automatically convert to the follow part cut pattern to handle all that geometry. Additionally, as we work our way down in cut levels here, you'll see that we're going to use the follow part cut pattern in any of that pocket geometry. So on a sample geometry like we have here, we have some pockets on the OD. We have the ability to specify range definitions for our depth of cut, as well as the ability to control when do we want to go into some of these pockets and when do we want to avoid them. A few different settings when we toggle on top off critical depths that we can go ahead and set by the amount of material that's going to be removed, decide do we want to go ahead and remove given material or not. So the common scenario here is if you have a very shallow pocket, you may want to leave that material behind and handle it with a semi-finish or finish operation on down the line. So a lot of flexibility built into the operation here. With our machining range group, we can limit our geometry based on radial containments or axial containments or a combination of both. So that's a great way to be able to limit your cut area based on axial positions or radial positions. So when we do this, we can select our positioning a few different ways. Perhaps you're working with a print in front of you and you want to limit by specific positions. You could go ahead and enter those numeric values, or use the dynamic handles to drag your radial or axial containments around. Or of course, we can just select geometry directly on our part to go ahead and find what the distance is, and obtain those values and use that to contain our geometry. And again, that works both with axial containments or radial containments. And like many other operations, we have the ability to apply corner smoothing to our toolpaths. Typically, you want to do this, save tool life and better finishes, but oftentimes we want to leave a square corner as much as possible inside of or at our last path to really form out the radius that you're using. We can also adjust our cut sequencing by level first or depth first. Again, very similar feel and appearance to other NX operations that you're likely comfortable with and used to. And looking at bottom-up cutting, if you use adaptive milling, you're probably familiar with bottom-up cutting, but this will enable you to walk back up your walls after you've cut to depth to really clean up any staircase effect when you have radiused or tapered walls. Okay, let's look at our conical depth mode. In this case, we can apply a cone angle, and have the toolpath apply to that same angle. That'll allow you to follow your part geometry, really alleviate leaving any steps, kind of a staircase effect, if you were to rough at just given diameter values all the way down your part. So we'll be removing more material in one operation than you would have had you used the cylindrical mode. So pretty interesting abilities there to handle that. So here we can see what a conical toolpath will look like. And it is important to realize that, yeah, you do need to have, in this scenario, typically a 5-axis machine to handle those positions, those rotary positions with essentially the tilt applied to the tool axis. And that brings us up to guiding curves and the enhancements that we can see in guiding curves. So we have 3 topics we're really going to be looking at. And the first one being how we can really control the tool axis a little bit at a more granular level. In this case, we have a new ability when we're using parametric interpolate that we can control not only across our cut pattern or along our cut pattern, but we can control both directions, both in the U and V of the surface drive region that we're cutting. Moving on, we can look, and now we can support multiple depths within this operation. So this is great when you're going to be going through and perhaps cutting up or cleaning small radius geometry that might have been roughed out with a larger diameter tool, and we leave geometry or blank material in the corner, and we're going to clean that up with a smaller tool. And instead of maybe stepping down 2, 3, 4 end mill sizes to clean it up, we can use the smallest tool required and just have multiple depths inside of one operation. So we'll take a look at some of the settings there and some of the flexibility in how we can manage that, those tool paths, and optimize things for number of engages or maximum reduction in cycle time. A lot of different options there. And the last thing we'll be talking about wall stock. We now have the ability to go ahead and specify wall geometry and apply a wall stock inside of this operation. Again, very similar workflow that you're likely used to in some basic planar operations like floor wall, to go ahead and control how much geometry and blank material you're going to be leaving for future operations. All right, so looking at the ability to control both the U and V directions. In this operation now, when we're looking at our tool axis interpolation, we can specify that, yes, we do want to control the U and V orientations of our tool axis. Prior to NX 1980, in these operations, we only had the ability to control along the drive or along or across the drive. So only our U or only the V, not both. And in this case, you see there's a lot of extra rotary motion in that tool axis. So if we come through and edit the operation and apply the control to both U and V, it becomes important on our vectors that we're specifying to make sure that our X and Y directions are related to each other the way that you would like to control the axis. So once we do this in this sample operation and generate the toolpath and replay this, you'll see that the toolpath, the amount of rotary positioning during the toolpath is greatly reduced, and this is going to really work to improve surface finishes, surface quality, really just minimizing the excess motions. And now looking at multiple depths. So multiple depths is now available, and this is again going to be very similar to other operations like contour profile, where you're probably used to having the ability to specify multiple depths. And this is a great scenario. We have a small radius on this part file that we need to go in and kind of remove, semi-finish, and then finish that geometry. So simply by toggling on the multiple depth cut, we can specify a part offset. So essentially, how much material are we saying is left behind? And then we can specify the increments or number of passes that we want to remove that material. So in our scenario here, we'll say that we're going to have 2 millimeters of material, and we want to incrementally remove a 1/4 millimeter at a time. So now the software does handle how it lays out the depth of the cuts a little bit differently, whether you're using increment as your step method or number of passes. When we're looking at increment, we're going to take our increment setting, and each level is going to be cutting that exact value, and then whatever the remainder is on the last depth of cut, NX will go ahead and remove that material. If you use a number of passes, NX is going to use the average depth of cut, and so you'll be removing the same amount of material with each step, as opposed to leaving a smaller amount on the last path. So once we do this, we are introducing some error cutting because we might utilize, if we look at our IPW, there's extra tool paths that we're offsetting and a little bit inefficient there. So if we go ahead and use our 3D IPW setting, we can clean that up. However, you see we have a lot of additional engages and retracts into our part geometry, and maybe we don't want that. Additionally, you can see along the last path, kind of the outer profile here, we have some of these lifts. And that can happen both along your part geometry or in some of the stepped passes here, just along your blank geometry. So we have two settings that we can play with. Apply to last path, we can toggle that on or off. And if you toggle that off, it'll force NX to just smooth out some of your passes, as well as applying a minimum cut material. Can additionally, the minimum material removed will clean up some of those tool paths, make them smoother when there's small amounts of geometry left behind. And perhaps to clean up some of these engages, we want to utilize our merge distance. And what this will do is, instead of when we're cutting air, engaging, repositioning, re-engaging the material, we can specify a merge distance. And maybe we have a small region that we're cutting air, and we're telling NX now, go ahead and merge those tool paths. We'll stay on the part, eliminating a lot of retracts, as well as we have the ability to change our cut pattern. Do we want to only go from the start of our guide curve to following to the opposite guide curve, or all the way through the geometry? We can also specify an inside-out pattern, or outside-in, where we can cut from the outer edges into the center of that radius. So a lot of different settings that we can go ahead and apply to really fine-tune the tool paths and make them most efficient and comfortable for machine operators. And the last topic that we'll take a look at here is the ability to assign wall geometry and wall stock. So you might want to use this new feature in this kind of a scenario where we want to apply or leave certain geometry as we're finishing this floor. We want to leave stock on the wall geometry. And we can kind of see in this case, yes, we want to leave a 0.5 millimeter, and even though there's tapered walls and things like that, it'll honor that setting. In the past, before having the ability to apply wall stock, we would have had to use the trim and extend functionality on our drive surface, and that's a little bit, a little bit of guess and check is involved there, based on the size of your geometry and what you're cutting, to go ahead and stay off those walls. Of course, if we're looking for really good finishes and high quality, typically we don't want to ask our tool to cut both on the bottom of the end mill and the side of the end mill. And that's where typically we would like to come back and not touch that wall geometry and come back and finish it later with a separate operation. All right, so that brings us into turning now. So Sandvik prime turning. This is something Sandvik's had out for, just a year or so now. And it's a kind of a completely new concept in turning. and it really utilizes chip thinning technology similar to what we see in high feed milling. So in brief here, we have two new insert geometries. It's an A-type insert, and this is for light finishing, or I'm sorry, light roughing, finishing, and profiling. And then we have the B-type insert that is really meant for just dedicated for roughing operations. So now we have the ability to support this because the cutting strategies are quite different. Essentially, they're really 180 degrees opposed to what you might be used to in turning operations. So here we have just a little simulation, then we'll look at a live demo cutting using this. But inside of NX, we have two new operation types, prime turning rough and prime turning finish. And to go along with those two new operation types, we have new insert types, new tooling types, our prime A and prime B inserts. So here, if you notice, we're cutting away from our work holding or our chuck, and that's to utilize the chip thinning technology with the new insert geometry. Typically required that, yes, we cut the opposite direction. So here you can see when we create a prime turning operation, we only have the ability to select the new prime inserts. And vice versa is true. You can only use the prime inserts with the new prime operations. So you can't use any conventional tooling with them. And with these operations, it's we can really utilize these tools on multitasking machines, standalone turning machines, and typically this is dedicated for steel applications at this point in time. Inside of NX, we have, I don't know, maybe a dozen or so tools included out of the box as examples of different Sandvik assemblies that can be used. But again, we can utilize these tools both in multi-axis machines here, or multitasking machines, I should say, as well as that A insert can actually be used for in combination with B axis turning for finishing operations. Now here in this live video, you'll see how we're engaging into the part and then feeding away from our workpiece. There's some interesting things that happen here on how we're able to do that. But again, utilizing chip thinning, there's very low cutting forces going on here, so that is why we're able to do this. This is kind of going against conventional wisdom of how you would go through and turn apart and hold apart. And here we have a little B-axis turning showing how that functionality is valid for this A insert type geometry. So if you use Sandvik prime turning, or you'd like to use it, it's now fully supported inside of NX in 1980. All right, and that'll bring us to our third section here, looking at some productivity enhancements. So this is kind of a small addition, but I think it's definitely a very beneficial add to the software, being able to utilize the 3D geometry that comes from a vendor for your tool holder data and import that into NX. So now typically in a milling scenario, we only really need a spun representation of our holder. We don't really care about keyways, flats on a collet nut, anything like that. So what the software is doing here, what this new feature is doing, this is now embedded in the holder tab when you're creating a tool. And we have a new option of holder source. And when we set this to solid body, we can go ahead and choose a solid body, a 3D model that we've imported, and specify a mounting location, and go ahead and extract the step parameters. So essentially, NX is going through and creating the tool holder just as you would had you been doing this manually with measuring each individual step of that holder. So it's just a big time savings, more accurate, and of course we can still save this data off to our tool library, reuse this just exactly as you would had you done all these measurements manually. So yeah, very nice while you're going through creating tool holders whenever you get new geometries, things like that. And we can still see every step along the way. So if we wanted to modify things, or perhaps you had one family of tool holders and different diameters, things like that, very quickly to recreate any of that data there. So here we went through, we're going to save this holder off to the tool library. And once we do that, we can go ahead and search and reload and reuse this holder in future part files. And here we can see, yep, we can go ahead and load our new holder that we just created. All right, tolerance class for tools. So this new field is valid for both reamers and boring bars. And again, we're going to want to be, or we are now able to specify what tolerance class that particular tool is. So I can tell if I'm using a 10F7 or 10H7 reamer, I know what tolerance is going to be associated with the feature that's being formed with that tool, as opposed to just the individual tool diameter. So whatever values you add into the tolerance class, now this is just a string field, a text field, so you can use, any tolerances that are applied or given to you from the manufacturer, or you could even come up with some of your own nomenclature for different tools and use this field. So now these tolerance classes are again made available to you in NX 1980, and you can add this field to any existing tools. And actually, inside of this first release of this, if you go and create a new reamer or boring bar inside of 1980, this field is not visible to you. So we have to go in and customize it into the dialog. So if you have a tool, you can right-click on it, our object customize, and from the customizable item group, you'll see that we have tolerance class available to us, and we can go ahead and add that to our tool dialog. And once we do that, we can go ahead and edit the reamer in this case and add some value to tolerance class and save that tool off to our library. And once you save it off to the library, you can then use that tolerance class field to search for tools. So I could go ahead and search for my 10H7 or a 12H7. And I wouldn't get any returns for if I had 10 H6 reamers or 10 F7 reamers. Likewise, we could use this information in feature-based machining to make more intelligent decisions. So we could have, look at PMI data off of what tolerance hole is and make tooling selections based on that combination. And the last topic we're going to talk about in this session is NC simulation. And we're going to be focused on the new multi-setup IPW workflow. So again, here's a common scenario. We have the first operation on one side of our tombstone. On another side of the tombstone, we'll have the secondary operation or tertiary operations. But the same scenario would work if you're on a vertical machine and you have two vices and you're flipping the part, or IPW settings while you're doing perhaps a mill turn setup, something like that. So a number of different use cases. All right, so we'll look into this new structure here a little bit. So right now we're looking at a multi-piece setup inside of 1980. And we can see it on the second operation, that's on the right side of our toolpath. We were able to see the current state of the IPW at the beginning of the operation. I'll talk about that here a little bit because that's going to go into what's changed here. So prior to 1980, and that's the scenario we're looking at right now, we really had two issues. One is that we had to go through and specify our geometry, all of our milling geometry, for each setup inside of the operation navigator. And once we did that, we had to jump into our machine tool navigator and essentially make all those geometry selections a second time. So there was redundant information that we had to input, and that can lead to human error, mistakes there, as well as just being time consuming, that you had to make the same setup selections twice. So that's the first error. The second error, we can see here, the parts on the right side of the tombstone that aren't being cut right now, they don't depict the material being removed from operation 1. So we always had this little bit of a disconnect in simulating the full process. And you can see now we're in 1980, we do see that operation 1 material that we're clamping on right now is showing as being removed. So there's one solution to fix both of these scenarios. When you go ahead and edit your workpiece, we can now specify a physical workpiece. So we can toggle that option on, and if we notice in our operation navigator, the little geometry symbol is now green. That's notating that physical workpiece is active. And from there, we can choose which machine component are we using as our kind of the following operation, or what was the previous operation is maybe a better way to say it. So this will allow me to go ahead and select and make that link and say, okay, this is where my IPW is coming from, this part 1 front setup, and transition that geometry to my secondary operation. And once you also make that connection, you no longer have to go into the Machine Tool Navigator and specify all that information redundantly there. If you have existing part files that have all these settings manually made, they'll still work as you've experienced in the past inside of 1980. However, if you want to implement and use Physical Workpiece, you have to go through and deselect all the geometry in your Machine Tool Navigator, and then make the Physical Workpiece connections there, and then everything will be updated to the latest and greatest workflow. All right, so that was covering the high-level topics of what is new in NX 1980 CAM. And we'll be back later today with some additional topics and a little bit more detail on some of these topics. Thank you.